In this video, I'm going to go over 3 of the problems that we did in class on Tuesday. So if you're already feeling really solid about the work we did Tuesday, you're welcome to skip this video, even though it might be helpful just to see things again. If you're one of the many students who reached out to me and said that you were still feeling pretty confused after Tuesday's lesson, that's totally understandable, right? This is some brand new content, so I'm going to just go over it. You can take your time with this, catch up on any notes. It might look a little bit different. Actually, I should say it does look a little bit different from what we did Tuesday because I just put this in a different situation, so hopefully it can make a little bit more sense for you all. So this first slide we're working at, so we're looking at algebraic expressions today. So remember, algebraic expressions, that means an expression that contains a variable, at least one. I'll just say expressions that contain variables. And again, typically you see x or y used, but a variable can really be anything. So our instructions are, using what you learned about properties of operations, write 2 different numeric expressions for the context below. So numeric means just numbers and operations. So this is like that formative we did where we were looking at all these situations and we were writing equivalent expressions. So we're going to write 2 different numeric expressions, and then we're going to write an algebraic expression. So in this story, Scarlett bought 5 apples for 35 cents each. Now, when we were doing this warm-up, 2 different students gave us 2 different expressions, and they were each equivalent. Kara said, well, that's like if we have 0.35 cents per apple, and Scarlett's buying 5 apples, then we can just multiply that by 5. And because we are now using x as a variable, I went ahead and rewrote this. And the same thing as if you put a 5 outside of some parentheses and 0.35 inside. That also means 5 times 0.35. So you have 5 apples multiplied by 35 cents will give us the amount of money that Scarlett spent. I was like, okay, well, what's another equivalent expression? And Mary, they were like, well, if she's buying 5 apples for 35 cents, that's kind of like saying, well, she spent 35 cents on one apple, and then 35 cents on the second one, and then 35 cents on the third one, and then 35 cents on the fourth one, and then 35 cents on the fifth one. So these are equivalent expressions. Multiplication is just repeated addition. 5 times 35 cents is going to be the same thing as 35 cents plus 35 cents plus 35 cents plus 35 cents plus 35 cents. Those will equal the same value. So then I said, how would this expression change if she spent 40 cents on each apple? So instead of 5 apples for 35 cents, she's buying 5 apples for 40 cents. So using Karis's method, we could say, well, that is like spending 40 cents. Whoops, that was 4 cents. Missed there. 40 cents 5 times. Again, with that parentheses, you read this as 5 times 40 cents. Using Mary's method, we could also say, well, she bought 5 apples. Each one costs 40 cents, so that's 40 cents. Plus 40 cents plus 40 cents plus 40 cents plus 40 cents. Again, these 2 expressions are equivalent, meaning they have the same value. They're just different. So now, what would happen if we don't know how much each apple costs? How could we write an expression? Well, anytime we have an unknown, we use a variable. So if we don't know how much each apple costs, we're going to say x equals the cost of the apple. No, cost of apple. And now where we would put the cost, we're just going to put x because we don't know that. So using Karas's method, we're buying 5 apples. And since we don't know how much we're spending, we're just going to put x there. 5 times x. Using Mary's method, we're going to say, well, we bought 1 apple for X dollars, and then another apple for X dollars, and then another apple for X dollars, and another one for X dollars, and another one for X dollars. Again, these are equivalent. One is saying 5 times x, the other one is saying x plus x plus x plus x plus x. All right, let's look at another example. So this is another one we did in class. I just switched it up a little bit. So we're going to follow this same format where first we're going to write numeric expressions and then we will write an algebraic expression. So in this story, Owen bought 3 songs. Each song costs $3. And then he bought a movie for $15. Write an expression of how much money Owen spent. Okay, let's start with Karas's method where we're using multiplication. So we have 3 songs, each cost $3. So we can write that as 3 times 3. Right, there's the number of songs. And that is the money per song. And then we also bought a movie, or we didn't. Owen sure did, though. So sorry, this is getting kind of messy, but that's a movie. So we bought 3 songs for $3 and a movie. Using Mary's method, we could say, well, there is the money we spent on one song, and then the money we spent on another song, and then the money we spent on another song, and then the money we spent on the movie. And all of that is our total. Equivalent expressions, right? So there's 3 songs, and then the movie. So how would the expression change if he spent $5 on each song? Same situation. Let's use Karas's method first. That's 3 songs multiplied by $5. So again, that is the number of songs. That 5 represents the money per song. And then plus that $15 for the movie. Using Mary's method, we would say, well, it's the price of our first song plus the price of our second song plus the price of our third song plus the movie. Again, right here we have our 3 songs and then our movie. So just like the example we did in the last one, now we're going to write an algebraic expression. So what if we didn't know how much money each song cost? We're going to say, since we don't know how much each song costs, we're going to say x equals dollar per song, right? That's our unknown. So when we don't know what a value is, we use a variable. And then we can start with Karis's method, where we say, well, we bought 3 songs. Each one cost X dollars, plus we bought a movie. So there's our number of songs. And then there's our price per song. And then there's our movie. Using Mary's method, our expression would be, there is the first song we purchased, and there's the second song we purchased, and there's the third song we purchased, and there's the movie. So there's 3 songs and the movie. And again, all of these expressions we're writing are equivalent. Let's check out one more example, and then I'm going to give you some practice problems to try on your own. Okay, this is the other one we did in class. So, starting with 12 jelly beans. 3 fell out of a hole in my pocket, and then a squirrel stole 3 more of my jelly beans. Write an expression for how many jelly beans are left. Okay, let's start this with our total. We have 12, and then I lost 3. They fell out of my pocket, and then I lost 3 more. Cool. There's one expression. I could also say that, let's say I started with 12 jelly beans, and then I lost 3 twice. 3 times 2. These will equal the same thing. If you have 12 minus 3, you end up with 9. You subtract 3 more, you end up with 6. And here, order of operations says we have to do our multiplication first. So 3 times 2 is 6. So this would be 12 minus 6, and that also equals 6. So these are equivalent expressions, and they both tell the story. How would that expression change if a squirrel stole 5 jelly beans instead? Well, I'll start with my total. I had 12, and then 3 of them fell out of my pocket, and then the squirrel stole 5. And I'm going to have to do something a little bit different here because I'm losing different amounts. But one thing I could do is I could say that, well, I had 12, and then the squirrel stole, well, then I lost. How about that? I'll call that. And then I lost 3 that originally fell out, plus the 5 the squirrel stole. So when I put those parentheses around that 3 and that 5, order of operations kind of groups those together. So this is the story of I had 12. So let's do the first one first. 12 minus 3 minus 5. 12 minus 3 is 9. 9 minus 5 is 4. So I can do that in steps. 9 minus 5. And then we have 4. So in this story, I had 4 jelly beans. And then here, in the 12 minus 3 plus 5, order of operations says I have to do that 3 plus 5 first. So this turns into 12 minus 8, which also equals 4. So both of those are equivalent expressions. Okay, now, what if we don't know how many jelly beans the squirrel stole? I'm going to call that X. And if the thing I don't know is the number of jelly beans stolen, then that's what X is going to stand for. X is number of stolen beans. So I'm going to follow a similar pattern here. And I'm going to say I started with 12 of them. And then I lost 3. And then the squirrel came along and stole an unknown number of beans. And then in my next round, another expression, an equivalent expression, I had 12 jelly beans. And then altogether, I lost the 3 that fell out of my pocket plus an unknown amount. And because we have a variable here, I can't simplify this down to a single value. So these are already simplified, more or less. We're good. We can let that be. These are our expressions. Okay, I'm going to give you some practice problems to look at now. Feel free to come back to these, use your notes, and if you're still feeling stuck, go ahead and just shoot me an email, and I'll try to help you get unstuck.